following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
And 3/500 kilograms of potatoes. Got that?
Yeah.
Okay, next. 5/10 of a case of soda.
Got it.
Okay, that's it. Can you ask them to deliver it to my house? Then we can take everything to school at once.
Sure. See you later.
Okay, bye.
Did you see what happened when Laura read her list to Maggie? There was a big difference between what Laura said and what Maggie wrote down. Those two are in for a big surprise. Let's see how they handle it.
The delivery man said there weren't quite as many potatoes as you ordered, but that they'd bring the rest over when they got them.
Are you kidding?
You tell me. You ordered them.
But is there a way in?
Yeah, if you're careful, you can scrunch past over there.
What are we gonna do?
I called Kate. I figured she'd think of something. She'll be over as soon as she's finished her homework.
Don't you think we should just call the supermarket?
Maggie, I think we should figure out what went wrong first. We still need some potatoes.
It's not funny. We're in big trouble.
Sure is big.
I thought before we called the market to pick up the potatoes and the soda.
Soda? You've got this much soda too? Where'd you stash it?
Not that much. Only 5 cases of 24.
It's here too. It's just kind of hard to see with all the potatoes.
Well, let's go over to my house and figure out what happened. Then we'll call the market.
Oh, I see what happened.
Laura, what did you say to Maggie?
4 3/500 kilograms of potatoes.
Oh, I heard 100, not hundreds. I didn't hear the th in hundreds. I thought you said 435. I didn't even think about hundreds being at the end of the number at all.
You've got a sort of lisp when you're saying hundreds. So how would you say this, Maggie?
4 and 35, I'm not sure.
4 3/500.
Why did Laura say and, Maggie?
I don't know.
And indicates where the decimal point is when you're saying mixed numbers out loud.
Oh, so when Laura said and, that was exactly where I should have put the decimal point.
Right. So do you understand the place values of each of the two numbers to the right of the decimal point?
Well, I know that when numbers are at the right of the decimal point, they're parts of whole numbers.
Right. So if you know that, how can you explain ordering 435 kilograms of potatoes?
Well, between slurring the th in hundreds and not knowing that and tells where to put the decimal point when you're saying a mixed number out loud, I really blew it.
That's okay, Maggie.
Now, what happened with the soda?
I just left the little old decimal point out. I guess I didn't really understand how important that decimal point was. But I sure do now.
It's easy to become confused about decimal placement, though it doesn't usually result in 335 kilograms of potatoes in your hallway. Maggie made her error because she really didn't understand just how important place value is. Let's take a look at these decimals and see what we come up with. Let's pick a number, say 421 and 376 thousandths. Now the 4 goes into what column? Of course, the hundreds. Next, the 2. Easy, the tens column. And then the 1. Right, the ones column. Now for the numbers to the right of the decimal point. First of all, the 3. It goes into the tenths column. Then the 7. Yes, that's it, into the hundredths column. Now for the 6. Right, it goes into the thousandths column. So it's read as 421 and 376 thousandths. Did you notice something about the numbers on each side of the decimal point? The numbers farthest to the left on each side of the decimal point have the largest value. Let's see what happens with a single number. If we start out with a 1 in the thousandths column, the 1 represents 1,000th. It would cover 1 square out of 1,000 on this diagram. Now, if we move a place to the left, the 1 represents 100th. It would cover 1 square out of 100 and is now 10 times greater in value. Move 1 more place to the left, and it now stands for 1/10th, or 1 square out of 10, and is again 10 times greater. It is the same with the whole numbers. It takes 10 tenths to make 1 whole, and you know that it takes 10 ones to make 1/10, and it takes 10 tenths to make 100. The place value system is the same on both sides of the decimal point. So every time you move 1 unit to the left, no matter which side of the decimal point you're on, you increase that number's value by 10.
Once upon a time, there was a one who was always wondering about the world. He lived happily enough with all his brothers and sisters.
9, 8, 7, 6, 5, 4,
3, 2, 1,
0.
And he was perfectly willing to move about them in hundreds, tens, and ones columns so that among them they could count any of the things around them, whether it was 1 apple, or 19 apples, or 199 apples. But one would also have liked to have been able to count little bits of things as well, such as 1/10 of a chocolate bar, or 1/100th of a house, or 1,000th of a Capitol building. But he couldn't do that because he was a whole number like the rest of his family, so he could only count whole things. But still, one couldn't help wondering. In fact, he did so much wondering that all the other numbers laughed at him and called him Wonder Boy.
There goes Wonder Boy.
Until one day, a little black dot dropped out of the sky. Wonder Boy reached out to count it.
You can't count me because my name is DP.
What?
Decimal point. At your service. I'm here to make your dream come true just by standing next to you.
I don't feel any different.
But if you stand to the right, you very well might.
I'm a 10th. Now I can count that piece of chocolate.
And if you stand 1 place further to the right, then you'll surely be a sight.
Oh, I'm 100th. Now I can count 100th of a house.
Move over some more, Wonder Boy, and then you'll really have some joy.
Gosh, now I'm 1,000th. And I can count a tiny little piece of that great big Capitol building. You're magic, DP.
Soon, all the other numbers wanted to join in too, and were able to count all sorts of interesting bits and pieces of things. And everybody was so grateful to Wonder Boy for his having discovered DP and his magic powers that they all agreed that he really was number 1.
It's really nice of you to help me measure the windows for the new curtains, Kate.
I love it, Laura. Measure, measure, measure.
My mom says that what we have to do is measure the length of the windows. Then she's going to buy the material. I can hardly wait. My room's going to be great.
But what about the width? Don't we have to measure the width of the windows too?
Nope, she just wants the length.
All right, I guess you've got to take what you can get.
I'll start here. Do you want to do the hall?
Sure. Well, that's it. Everything we need.
Great. I'm finished too. I can add the lengths myself.
Come on, Laura, be a pal. Let me do it.
Kate, you're something else. Oh, no.
What?
I measured mine in centimeters, and you measured yours in millimeters and decimeters. How are we going to add them together?
It's okay, Laura. I'll show you how.
Kate, is this something you dreamed up on purpose?
Would I do that?
Why do you always have to do things the hard way?
This isn't hard. Honest. Listen, there are 100 centimeters in a meter, so that means that 1 centimeter is 1/100th of a meter. Since we have 98 centimeters, how would you write 98 hundredths as a decimal?
Oh, I get it. 98 hundredths. That's 2 windows that are 98 hundredths. And then there are 91 centimeters, 91 hundredths. 53 centimeters, 53 hundredths. 720 millimeters.
Milli means thousand. There are 1,000 millimeters in a meter, so that means that 1 millimeter is 1,000th. Since it's 720 millimeters, how would you write 720?
Don't tell me. 720 thousandths. 386 millimeters, 386 thousandths.
Why don't you write for a while?
Okay. Shoot.
The next ones are in decimeters. Deci means 10. There are 10 decimeters in a meter, so that means 7
tenths.
Do you mind if I do one?
Go ahead.
There are 2 windows that are 7 decimeters each.
Okay.
There are 3 windows that are 9 decimeters each, 9 tenths. That's it, finished. I suppose you want to add them up by yourself, too.
Admit it, Kate. You measured yours in millimeters and decimeters on purpose, so we'd have to change them to decimals, didn't you?
We'd have had to do that when we added up all the centimeters anyway. And it was more fun to measure so we could do a few more decimals. But you did most of them yourself.
I knew it, you know. I just knew you did that on purpose.
Well, you fixed me, didn't you? I didn't know you were so good at decimals.
Why wouldn't I be? Got a great teacher.
In world-class downhill skiing, the difference between winning and losing a race can be measured in as little as a tenth or even 100th of a second. But before these skiers get to the slopes and in between races, they all have to maintain a training schedule that is exhausting even to watch. The discipline is hard, the tension is constant. It has to be when you're striving to be the best in the world. Their lives consist of working out, practice races, and the big competitions. Watch this skier. The time on the left is the one to beat. And he doesn't make it. So what's it all about, this hurtling down a mountain at breakneck speed? It's trying to beat the clock, and the scores can be so close that it's that 100th of a second that makes or breaks a winner. A win by 42 hundredths of a second. Wow.
Well, it must be pretty clear by now that place value in decimals is important, even if you don't end up with a hallway full of potatoes.
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation. This program is produced by Sail Away Productions under the supervision of the Agency for Instructional Technology.